radius A, thin shell, both are thin shells, mass M1 and M2. They are separated by a distance R. No. Where R is very much greater than A, very much greater than B. What is the total energy of system? The total energy of system is self energy plus interaction potential. What is the self energy? Self energy of this shell. So what is the formula? G M1 square by 2A. Self energy of this shell, G M2 square by 2B. Then interaction potential G, G M1 M2 by R. I will do like this. Okay, got this one. So the interaction potential is different from the self energy. What is UI? UI will become interaction potential. US will become self energy, and this will become total energy. This UI is what, sir, why you are writing G M1, M2? Because they are separated by large distance, R very much greater than A. Then how do these two will appear? Like a point mass. So I'm treating G M1, M2 by R. So there's a one formula like this, we'll write it. And this, you look at these two quantities. They are called like a self energy. So there's a difference between interaction. Don't think again that interaction potential is self energy. No, self energy is what? Work done by X-ray agent to mechanical work done by X-ray agent to construct a system. This interaction is due to gravitational field. If you take them to infinity, then this interaction will become zero. So interaction potential of a thin shell, I think we should not discuss. Interaction between two objects will come. Self energy for individual object. What is the self energy between objects? Wrong way of asking. Able to understand? I'm trying to give the basic idea. We should never say self energy between the two objects. Wrong thing. The quantity itself is not defined. Self energy is defined for a given system. Interaction potential is defined for a pair of a system. This is for a system. This is for pair of a system. Okay, there's a one basic difference there. Now I release them. If I release them, tell me what will happen to that. They'll start accelerating. Then which energy will decrease? The self energy will remain constant. The interaction potential just decreases here. So let me take small diagram. Two shells are there. Radius B, and they're separated by a distance say like a R. Now finally the separation has become, okay, we can't. I'm interested in this one. Yeah. So the separation has become X now. Earlier it was R, now it is X. So when I go and check it, no, they're moving with the speed V1, V2. From where this kinetic energy for the shells has come, the decrease in potential energy got connected to increase in kinetic energy. But what will happen to the self energy? Self energy will remain same as it is. So which energy is decreasing? Not self energy, interaction potential. Then what is the equation we write it? G M1 M2 by R equal to G M1 M2 X plus then conservation of linear momentum. Release from rest, release from rest. There's a basic idea. So the decrease in interaction potential G got converted into increase in kinetic energy. Self energy of the shells will remain as it is. Agree now? This is now there is a